However, this will be part 4 of the pendulum, and I want to look over connections, but also make one correction as well. But first, so where's my ruler? Okay, so we have the standard metre ruler, and that's now defined by the speed of light per second, which is relevant to pendulums and 1 second. But I'll be looking at other units of measurement. So firstly, okay, we have our our 1 metre as defined by the speed of light. We also have 1.00584 metres, I'll come to that in a second. And underneath we have this metre, which is exactly 1 second. So since the 1640s, Mercer and Riccioli, but 1790s, George Washington, Jefferson, Talleyrand, we're going to introduce, this has the metre. In the case of America, this would 33 centimetres, 0.14 millimetres would have been an American foot. So 1 American yard would have been effectively the French metre defined by a 1 second pendulum at 45 degrees, which is this number. Now you have the speed of light meter. Now all pendulums I covered earlier can't go more than 30 degrees, it affects the timing. But so if we have a pendulum which is still going to give you very, very, very close to a second, defined 1 metre, standard metre defined by a speed of light as is current since 1984. Therefore, this section of arc is exactly pi over 6 metres, which is 0.52359 metres, which is 1 Egyptian raw cubit, as has been understood at least since the 1920s. So 1 Egyptian raw cubit from the tip of your elbow to the tip of your longest finger, ideally speaking, but the actual measurement is pi over 6 metres. And then it was divided into palms, so 4 fingers, 1, 2, 3, 4, 5, 6, 7. And each one of those was 4 fingers, so 28 fingers, or 4 palm, so 1 palm, and then divided into 4 fingers. 1, 2, 3, 4. Now 4 7, so you have 3 sevenths, now you have 4 sevenths of that. Let's just call that an Egyptian foot for the moment, and we compare that to the official 12-inch foot that we're used to. So 1 centimetre basically your fingernail, and your width of your thumb basically 1 inch. The difference between 1 standard modern English foot as defined now, 30 centimetres, 4.8 millimetres, 0.3408 metres. When I refer to a metre, I'll always be referring to the modern definition of 1000 millimetres, which defines so this speed of light metre defines the Egyptian raw cubit through the pendulum. Length and time are connected. Now, I covered it earlier, but let's so 0.3408 minus 0.299199 in millimetres, that turns out to be 5.601 millimetres. Now this metre, speed of light metre, which defines the Egyptian raw cubit, is 1 metre minus 0.99438 metres, which was going to be the yard in the US, or the metre in France in 1790s, is the difference. difference there is 5.602 metres. So as an example, the margin of error between 4/7 of an Egyptian royal cubit from the English foot is 1/1000th of a millimetre from this pendulum, which defines exactly 1 second at 45 degrees. Okay, I mentioned that, but now, so that's this metre here. Okay, so we also have the speed of light metre here, but now I want to talk about this metre, which is 1.00584 metres. And now let's pretend I've made this pendulum longer. So we've already shown this, the Egyptian cubit and the foot connection through the metre. The margin of error actually, gives us that difference. Now if I extend the pendulum, let's just say I've extended it to 1.00584 metres. Okay, so that margin of error we saw was 5.601 or 5.602. So now we're adding 5.84 millimetres. So again, now the difference, if we subtract this from the metre, we get the exactly 1 second pendulum. If we add that, we're 0.24, 1/4 of a millimetre. That's about a couple of hairs. So now if that margin of error, so 1 metre minus this, we get 0.99438, which is exactly 1 second. If we add it, now we get this slightly longer pendulum, again within 0.20, I can put it in 0.00024 metres. That's the difference from the margin of error, which gives us this info. This pendulum is important. Okay, as I already mentioned, so this exactly 1 metre speed of light definition is 1 Egyptian royal cubit. 1 Egyptian royal cubit is pi over 6 metres, or E minus 1 feet within a fraction of a hair. E is this very important constant. Pi and phi of these constants, will come to those. But so how these connect now? Now I've extended the metre. Now I didn't actually physically extend it, but just to get the point of it across. Now if you create a pendulum this long, the length of this arc will be 0.52656 metres, which is basically one Egyptian royal cubit plus 3 millimetres. So minus 3 millimetres, we'd have equals an ERC. Now the Egyptian royal cubit in feet is 1.71799, which is again E minus 1 within a fraction of a hair. This one converts to, in feet, is 1.7 feet, which is again a fraction of a hair from a canonical cubit, which is John Michel and Robin Heath spoke about, which is 6/5 cubed feet, or 1.728. What's that? 0.0013 feet from a canonical cubit. This also is important because this 1.0584 is exactly 3.3 feet, which is equal to 3 Indus feet. Therefore, by definition, this section of arc is going to be exactly pi over 2 Indus feet. But that's just the nature of things. But essentially, so this is now a canonical cubit or an Egyptian raw cubit plus 3 millimeters. So we have a canonical cubit of 6 over 5 cubed feet. And what's important is, so what we have is the Egyptian roll cubit, which defines the pyramids, which is defined by 1 speed of light metre on the pendulum. And now we have a look, so Sumer and Babylon here in Mesopotamia, and the Indus Valley civilization. These three, not including China for the moment, we have these three ancient civilizations and how do they connect? Well, so this is equal 1.0058 metres is 3 Indus feet. Now the Indus foot so 1 Indus foot. This again found by measuring rods, this is known, equals 1.1 English feet. Okay, so you can see it here. So 1 English foot equals 1.1 Indus feet, or 13.23 inches. What's interesting is that the Royal Babylonian foot and cubit are a ratio of 1 to 1 to the modern English system. So both of these are 1.1 in ratio to the English foot that we're used to, the standard foot. But the Saxon foot's the same, we'll come to that in a second. So both these cubits defined by these pendulums go a long way to describing the pyramids. And so, for instance, you stand at a corner of the pyramids, and what you're going to see is 440. This is the Great Pyramid, 440, and 280 Royal Egyptian cubits high. So that's just the pyramid itself. If I stand at the pyramid, I multiply pi over 6 metres by 880, I get the maximum visible base length. If I stand at anywhere on the pyramids and I multiply pi over 6 metres by 280, I get the height. Now if I stand, still at the corner again, and there are slight variations in each side, so I'm just to get it across. Now you also have the sockets, and you have the paving stone, which gives it extra height, and the sockets give it extra width. This pendulum times by 880 defines this. The extra length by the sockets is defined by that pendulum at 880. Okay, so the pyramid times pi over 6 metres, 880 maximum visible base length. The Great Pyramid, including the sockets, maximum visible base length times 880, that's defining the same thing, and 280 Royal Egyptian cubits high. This pendulum multiplied by 280 defines the height of a pyramid, including the paving stone. Now throughout the pyramid, so the connection between the metre and the pyramid, I'll do that in a separate bit. The Great Pyramid, if you measure it in speed of light metres, the ratios between them always leads to phi and pi throughout it. And again, this could all be defined as coincidence, but how many coincidences, but that will be for something else. Now, what I do want to correct is that in the previous episode, I said that the distance, so this from here to here is going to be exactly half the length of that. So the Indus foot is equal to the Royal Babylonian and the Saxon, but firstly the Royal Babylonian foot, Royal Babylonian cubit, which was used to define Epic of Gilgamesh in these old Tablet 11 and others, but one Royal Babylonian foot is 1.1 English feet, so therefore this is also 3 Royal Babylonian feet long, and there are 1.5 feet equals a cubit, so that's 3 Royal Babylonian feet. Therefore, I just guessed it, half the length of this is just because of the geometry, it's going to be exactly the length of that line across, and that turns out to be, in the previous video I said half the length, but the full length of this across is 1.42857 repeated in cremona feet, which is this older unit of measure. I've got evidence for it in Greece and stuff, so on, but it was used up until about the 1800s and it disappeared. And why? So the square root of 2, which was known about in ages back past, so Plimpton 332, square root of 2 equals 1.4142. Where is that? I think it's in 135. Okay, so this is 14142. 857. That's 1/10, 100th, 1,000th, 1/10 of thousandths, 100th. So that's 7 over 100,000. Okay, so the number might look different, but to get that level of accuracy again is very important. Now, the cremona foot is 6 over 7 feet, or 1 cremona foot is 14 inches, which is a nice connection for a lot of ways because of the importance of 7. Okay, so that's, I've corrected that, but and the connections to the pyramids, there are lots. I'll put that separately. I've already done some videos, phi, pi, the meter, the geometry in the pyramids as well. Brilliant stuff. It can't be coincidence because it's full of geometric knowledge, pretty advanced math stuff, and well, that it's in the proportions of the pyramid gives you phi and pi, but everything that's repeated in ratio is again repeated in measure, especially for even metre, the modern definition speed of light metre. But what also connects, so this is 3 Indus feet, or 3 Royal Babylonian feet, which is at a ratio of 1.1 feet. Well, that just happens to be the same as the Saxon foot, which was used over here up until the late 1500s. And so the exact date is 1583, Queen Elizabeth I. Got fire on my head. The 1583, the Weights and Measures Act of Parliament introduced the English foot as we know it now. So 1 foot, okay, 1 mile equals 5,280 feet. The definition we have now. This goes back to 1583, Queen Elizabeth I and Edmund Gunter. Clergyman, astronomer, geometrician, he's the one who, that's when officially this was brought in. Now, prior to this, an English mile was 400 4,800 feet, but the Saxon foot is 1.1, so if you multiply this by 1.1 you get 5,280 feet. All they did was shift the unit. The measures stayed the same. And that's important because this will now connect to the King James Bible version. So pyramid connections, Epic of Gilgamesh connections, because the Epic of Gilgamesh in tablet 11, in the Epic of Gilgamesh he described the preserver of life, or the ark, and that was 120. Okay, so pyramid connections, I think we'll do this for a moment. Now we go to this ancient text. An older version has been found and it describes this preserver of life, or this ark of Gilgamesh, Gilgamesh's ancestor, actually the great flood story. Now it's this older description sort of is more like one of these round boats that they use. But in the 1500 BC, they describe it as a cube. So that's the original ark, preserver of life, Ark of Utnapistim, and that's at 120 Royal Babylonian cubits, or 180 Royal Babylonian feet. So this is now points to this, describing this cube. Now there's so much 108, 144, all these numbers connect in there, but at the same time as all this was going on, right after Queen Elizabeth I and these measures were brought in. Okay, so one of the important measures that Gunter brought in is also called, it's still now called the Gunter's chain, and it's a standard street width across the world. It's very important. A Gunter's chain, or a surveyor's chain. So if you're in the US, Canada, Australia, your street width is either probably 66 or 132 feet for highways, but that's what a Gunter's chain is, 66 feet. So think of that, 3.3, but and that's 792 inches, which is, well, sun, earth, moon, all these other numbers. But what's important about that, and this point in history, is after Queen Elizabeth I, we have King James I. Now he introduced the Royal Mile into Scotland, but more importantly, the King James Bible, King James version of the Bible was brought in, and so directly right after Gunter brought in the English foot, 5,280 feet per mile, and removed the Saxon foot, which was exactly the Royal Babylonian, or the Indus, as is used here, which gives us this pendulum, which describes a pyramid, which is a square root of 2 in Cremona. King James I also did the first English Bible, and they describe New Jerusalem. The older Bibles will describe New Jerusalem as 12,000 by 12,000 by 12,000 stadia. So 120 cubits by 120 by 120 from the Epic of Gilgamesh. And then we have the New Jerusalem comes in, and it's 12,000 furlongs now. Previous older versions will, but the King James Bible now says it's a furlong. We know exactly what a furlong is. It's 10 chains. So 1 furlong is 660 feet, or 10 Gunter's chain. 660 feet. And well, what's nice about it now is so much to get from there, because you get all the metrology and stuff going on, but that works out to be 79250 feet long, which turns out to be exactly 241,406 meters. Exactly. You can put it into your conversion. 79,200,000 feet. This is all 1,500. Okay, 1,500 miles is what this converts to as well, miles, and that converts exactly to meters. 2414060 of these meters, which describes the pyramids and the Royal Egyptian cubit. And so whether it's in the Ark of Utnapistim, because this is going to give you 108, 144, all these lovely numbers and conversions between multiple units. So the Saxon, the Royal Babylonian and the Indus foot are all 1.1 or 13.2 inches, which would have called, okay, so this, the preserver of life would be at 132 feet high, wide and long, or 2 Gunter's chain. 66 times 2 is 132. And then you have New Jerusalem, which is now, since the King James Bible of a version, King James Bible version, they swapped the description of New Jerusalem from stadia, which is a bit confusing, to the furlong. We know exactly what the furlong was because it was introduced in 1583 and it's still the official standard now. That's exactly 1500 miles as we understand English miles, and that converts exactly to meters as well, and that's this speed of light meter which describes the Egyptian royal cubit. So what you have going on through all of these scales, now history will tell you a foot was defined by some random king's foot, and they'll tend to say, oh, all of these things are unconnected because all of these civilizations were not connected. Well, the Indus were using 27.3 grams way back at the beginning. The Egyptians were using 27.3 grams. The US silver dollar is 27.3 grams. That's written into the constitution. And the Spanish and especially the colonial period, they were using 27.3 grams, and so were the ancient Greeks and Romans. The Islamic counts is 27.3 grams, and you'll find it all across the ancient world. It's been since the beginnings with the Indus in Egypt, it's carried through us, and that's so as these measure systems, weights and measures. Actually, it's seen as dry or just because we're taught, or just a foot is just a random foot, it's just a random unit. No, not at all. It connects to time. It connects to these ancient legends. It connects to the size of the sun, the earth and the moon, the distances between them. All the numbers that emerge from here are the ones that are pass on so much information, and so the so-called margins of error, so for instance between the English and the Egyptian foot, is exactly the difference between 1 speed of light meter and 1 second meter. And well, now you add that to the meter, and within 0.2 of a millimeter, what you get is 3.3 feet or 3 Indus or Royal Babylonian or Saxon. So a Saxon yard, which would be, so 1 Royal Babylonian plus an Indus foot plus a Saxon foot, 3 feet is a Saxon yard. That was used up until this point in time, and Queen Elizabeth I. Edmund Gunter was so much connected with Queen Elizabeth, connected with John Dee, and all these very mysterious hermetic period of time. This was the time when these weights and measures were being standardized, when they were mapping the world. Edmund Gunter also, amongst other things, he did the quadrant, which was a system for measuring angles of stars and so forth. It was also used to measure for navigators when they were drawing their first map. So Francis Drake, John Dee, Bacon, and then you have also the Bard Code. Alan Green talks about the Shakespearean equation and these things that are written into Shakespeare and embedded in there. And it's actually all connected here, and it connects the pyramids, the Ark of Utnapistim, this old flood story, the New Jerusalem in the King James Bible version. What they've done is they've just shifted stadia to furlong. We know exactly, they argue what a stadia or a stadium, this old unit, there's different variants of it, but we do know what a furlong is. And so just after Queen Elizabeth, King James I embedded all this stuff in here, and it just exactly happens to convert. That's the point where where feet and meters connect. Now this is also an exact conversion point between several other scales of ancient units of measure, not just for whole numbers, that's nice enough, but the numbers come to harmonics, Pythagorean harmonics, which is so important for music theory, but they're also described sun, earth and moon diameter relative to one another on the harmonic scale. And so time, length, pretty advanced geometry, including the square root of 2, e, pi, and Great Pyramid. If you read it as modern speed or light meters, you get phi, pi, e, the area of circles in squares, the volume of spheres in cubes. Very advanced geometry, and it can't be a coincidence, all of it. It can't be. It's just too much. If it was just a few, okay, but at some point coincidence becomes a pattern, and you can measure it. Thoth, God weights and measures. Hermes, Hermeticism, God weights and measures. This is how they embedded in legend, in units of measure, and in physical structures such as the Parthenon, Stonehenge, Karnak in France, Aindara, ancient Indian temples as well. All across the world, the same units of weights and measure that are apparently unconnected come back to the same cycle. They fold in on one another. And yeah, so with a few scraps of info, we make pretty big assumptions about, for instance, Old Kingdom history. But if you mention this in regards to them, they say, oh, well, there's no evidence and stuff. Well, this level of data coming together is many more data points than what is traditionally accepted as acceptable level of information. I don't get it. But yep, weights and measures, these different systems actually connect. The margins of error between them also point to some very advanced physics, geometry, astronomy, and the people who were, especially in the 1600s, who were so involved in them, such as the development of the pendulum, Mersenne and Riccioli, or Edmund Gunter, Albrecht Dürer, all Kumraf and these other alchemists, through their symbols in their illustrations and their writings, it's all coming back to the same thing. They were they were Hermeticists in the sense of Hermes, God and weights and measures, God of weights and measure, and Thoth, God and weights and measure. Hermes and Thoth were also the gods of science and knowledge. And how would you pass this information on? Well, you do it through number and measure. Man is a measure of all things. So for instance, your thumb is an inch, your small finger is a centimetre, the wrist to your elbow is it's a feet. And okay, also interesting that 1 metre, this speed of light meter, is from your foot to your belly button is 1 metre, and then from there to your head it would be plus 1 cubit plus 1 foot would describe someone who is exactly 6 feet, and that has all these applications to the pendulum. So 1 cubit plus 1 metre plus 1 English foot is 6 feet. Pretty much, it's hard to say what is exactly ideal, but it's a very good measure of a man. And yeah, it all blends together. And again, just to correct the last one, I said halfway across was square root of 2 Cremona feet. It's actually all the way across, which is exactly 1 Royal Babylonian cubit, or half of this length. Phi, pi, e, all these other constants is all here. The second. Yep, have a good one.